Today what we are going to do is we are going to learn descriptive statistics, and we'll see how we can actually do these things on Excel by using simply the Excel functions, or we can use the data analysis tool pack which is there in Excel, or we can use the Excel templates. Now obviously the Excel functions takes a little bit more time. Data analysis tool pack is much more handy, whereas Excel templates are, you know, very time saving templates, and they give you much more information as you might get while using Excel in comparison Excel functions or data analysis tool pack. So let's assume that you are given a data like this, and the question may be asked that generate the summary statistics of the data given, and you have some data which has been taken. So these are different data, and what you have to do is you have to generate the summary statistics. So you may be asked to generate the statistics, or you may have to do it on your own, in the sense that you may be asked, okay, what is the median? Identify the median, the mode, the quartile ranges, interquartile ranges, what is range. So sometimes you may be asked for a specific summary statistic, or you may have to generate all the statistics. So what will we do, right? So if we have to look at the summary statistics like mean, median, mode, standard deviation, variance, skewness, kurtosis, what is the range, what are the different quartiles, first quartile, third quartile, what is the interquartile range, what are the outliers in this particular data set. Outliers I'll explain, extensively. And then what is the sum, what is the count, what is the minimum, what is the maximum. So we can do all these things with the help of Excel. So the first thing that we'll be doing is we'll go to Excel and we input the data that we have. Now, once we have done this, we can see the data is, we have just input the data. This is not, the data has not been ordered. It has not been arranged to, but in Excel, it's very easy. All of us can arrange the data. We can simply arrange the data and by using the sort function. So in this example, we'll go and select this. We'll go to sort and we'll go to sort smallest and largest, and automatically the data has been sorted. Now I'll just copy this data to another sheet, and this is the sheet. And what I've done is I've added the serial number on this side, okay, just to show that these data they're coming from different people or different objects. So we have the data, this is the sorted data, and this is the statistic that we want. Now, for example, if we want the mean, so what we'll do is we can simply use this function. So either we can click on this function, or I mean, this is good for people who are just beginning with the statistics and Excel, or people who are just started using Excel. They can click on this, and once you click on this, it will open up, and you can just type whatever you want. Now the first thing we are interested in, either we can type the function that we want here, or we can select the most recently used ones, or some of the options would be here by default, like for example average. Now in Excel there is nothing like mean, okay, and the word that we use in Excel, or the function that we use Excel, is average. They are basically the same thing. This has already been explained earlier to you. So what we'll do is we'll click on average and we'll hit the button. Okay, now it is asking us the data set. Okay, so we have to go and select the data set, the entire data set, and we'll hit the button and we'll say okay. Now it is saying number 2. This is for situations where we have multiple data sets, like for example different groups, different data sets. If we, in this case, we just have one data set, okay, and let's assume that you would have had another data set 2, and you would have had some values here. We could have put these values here, okay. So we are only interested in the mean, and as you can see, the software automatically tells me the mean, and the mean is here 52.266. It has already given me the mean. That is one way to do it. So once you become familiar with Excel, you will probably not be using this. You'll be using the shortcut keys. So if I want to find the mean, I'll just go and hit equal to, and I'll write AVG, where it will give me average, the second one. So I'll click on the average. I'll select the data that I want to. So these are my data, and I'll just close the bracket and I'll hit the button enter. It will give me the average, which is the same which we just saw. Similarly for median, I'll write median, and I'll get the median. And the same process I'll use for median. So I'll, again, it is saying number one, number two. Like for example, if you would have had multiple data sets or multiple variables, we could have done the same thing. So in this, we're going to select the data. We have only one variable which is written as data, and we'll just, enter it and we'll get the median. Same is the case with mode. So we can do the same thing for mode also. We'll just write mode and we'll get the command for mode, and we'll just identify the data to the software, hit the button enter. It gives standard deviation the same way. Now, standard deviation, one thing that you need to know is very, very interesting. When you hit this, if you write STD, okay, standard, so it says, if you go down, you'll see there is STDEVP, which I've highlighted, and STDEV S. What do these things mean? These things are very, very simple. When we are calculating the standard deviation for population, we'll use stdv.p. Otherwise, if you are doing it for a sample, we'll do it stdev.s. So in this case, we don't know whether the data is from a sample or from a population. Or the population could be of only 15 people or 15 objects. So we don't know. So we can either assume stdevp or we can assume stdvs, unless and until it is given explicitly, or we know we can use either one of them. So I'll use stdevp, and the same thing, I'll just do this and I'll hit the button enter and I get it. Now if I want to do for the sample, I'll use the same command stdev and I'll go for sample now. Okay, so I can do it for the sample and I'll hit the button enter. Now you can see for the sample the standard deviation is more. Why? Because in the denominator, if you remember the formula, it used to be n minus 1 under root n minus 1. So when it is n minus 1, there is the correction factor. Obviously the numerator would become bigger, the denominator would become smaller, and that is why the standard deviation is more. The third thing that you can do is you can just simply hit the button enter STDEV, and as you can go down, you can simply see there is standard deviation. Okay, and when you hit click on this, it says this function is available for compatibility with Excel 2007 and earlier. Estimates standard deviation based on sample, ignores logical values and text in the sample. So you can just hit STDV. Again, you can do this and hit the button enter. It will give you the standard deviation. Now, in order to find the variance is basically the square of your, this is basically, just write star same value and enter it. This gives you the standard deviation. So similarly, you can do for the rest of them. Skewness, if you want to find the skewness, you just hit the button equal to and write S key, you get skewness. Now, what you can do is you can just simply click this. Again, it will ask you if there are different variables, you only have one variable and the data for that particular variable. Enter it, you will get the value for the skewness. Kurtosis also, you will get the value for, you just write KURT and you will get the kurtosis. Enter, you will get the value. Sum, you just write equal to sum and it returns the value for all the numbers. So you can just write the sum for all these. It will give you the sum. Count, use the count function and it will give you the count of the total data points. That is 15. Minimum equal to MIN. It will, when you write MIN and just all the numbers, it will give you the minimum is 6, which you can see you already sorted it. You can see visually, you can see the minimum is 6 and the maximum is 155. But if the data set is very large, not arranged, not ordered, then you may have a problem. You write maximum and you will get the maximum value. Select, enter. Range, now range is maximum minus minimum or minimum minus maximum absolute value. So this will become, you can write equal to 155 minus 6, and that is your range. Now when we come to quartiles, we all know that we have the median is the second quartile or the middle quartile, the first quartile is the 25th percentile, and the 75th percentile is the third quartile. So in order to find the quartile, what we can do is we can find the first and the third. The second is already known to us in the form of median. So what we can do is we can simply calculate the first quartile or the third quartile first, or whichever you want. You just write QUAR. So once you write this, you'll get the quartile. And in this quartile, you have to assign the data. And the second thing is comma, and you have to whether you want the first quartile or the third quartile. So you write the first quartile. So because you want the first quartile and enter. So you get the first quartile. Similarly, if you want to find the third quartile, you can simply equal to quartile QUA, and when you come to quartile, double click this, select the data, and comma the third quartile. Now you're interested in the third quartile and enter. So you have both the quartiles. And what is the interquartile range? The third quartile minus the first quartile. Okay, and you can minus first or third or first. You have to write the absolute value. So we will do it like this: equal to the third quartile minus the first quartile, and that is your interquartile range. Now, when you come to outliers, this is an interesting concept. How do you identify the outliers? One way to do it is just to visually look at the data, and when the data set is small. So example, in this case, we can simply see that if you look at the values, this is 20 and this is 76. But if you look at the last value, 155, it appears 76 and 145, in 155, there's a big difference here. And similarly, 20 and 6. So visually, 6 and 155, they both appear to be outliers. So unless and until it is asked to do it, you know, to have a mathematical basis or to have a statistical basis in identifying outliers, one way to do it is just by looking at the data like this. And with this, we can simply say that by looking at the data, we can say that the outliers look like to be 6 and your 155. But this may not be correct. Okay. So what you can do is you can actually take the entire data, and the best way to do it is to have a look at it through you know charts and graphs. So one way to look at this is you can just select the entire data and you can go to insert. When you go to insert, you can see different options. And what you can probably do is either you can go to the recommended charts or you can go to the statistics, insert a statistics chart. So in this, you can insert a histogram. So you just insert a histogram and you get the histogram here. And now this histogram is not very interesting to us for the simple reason, we cannot we cannot, understand too many things from this. So what we'll do is we'll simply delete this. And what we'll do is we'll go back again and we'll go to insert, and the chart that we want is box and whisker plot. Okay, so this is an interesting one. And what it will do is it will generate, I'll just bring it here as you can see for yourself, and I'll just try to increase the size of this so things becomes much more clearer to you. So you can see what has happened is, if you look at this chart is a very interesting chart, and it tells us a few things. If you look at this chart tells us that this value that you see, the dot that you see, is basically an outlier. So 155 from the box plot is an outlier. And what is this x that you see? The x that you see is actually your mean. So the x that you see is the mean value, which you have calculated, 52.267. You can see this is your mean value. It's the same thing, rounded off to the nearest decimal. Then you have, other, what you call as things, like example, the first value that you see, the smallest one. Okay. And then you see this is the other one. Okay. So what are these? What are these values? What is this? These are the things that you need to understand in the box plot. So that I'll do it in a separate discussion, because we are short of time and this lecture is only on identifying this box plot. Box and whisker plot was made to demonstrate how we can find out the outliers. There is another way to find out the outliers, and that is through computing the z values. But if you are asked in the exam to identify outliers. So you can simply just have a look at the data and see the data which are not consistent with the rest of the data. Like example, in this case 155 and 6 are not consistent. So you can simply identify that. You will probably not be asked to identify outliers with the help of, you may be, you may not be. I'm just saying, if unless and until you are asked to identify outliers with the help of a box plot or the Z values, you need not do that. You just visually examine the data, like we can see here, sort the data, look at those values which do not gel or do not look consistent with the other values. And once those are not consistent, like for example the 6 and 155 on the first glance do not appear to be consistent, so we'll say that these are outliers. Now, if you really want to find out the outliers, whether they are outliers or not, there is another test which is called as the graphical visualization, which we just did. And if you really want to be more certain, then you have to find out with the help of the calculating the Z values, and on that particular basis you have to identify whether they are an outlier or not. But again, whether a data is an outlier, whether a data point is an outlier or not, it all depends on your perspective. So when we are talking of the Z values, we look at the standard distribution, and from the standard distribution we say that anything which is beyond plus minus three standard deviations away are outliers. That is one way of visualizing the outlier. Somebody might say, no, why three? It could be four standard deviation away. Ultimately, everything depends on the researcher's perspective. But if you are asked in an exam without specifying which way you are going to use, you just have to look at the data, and at the first glance, preliminary outliers appear to be or seem to be 6 and 155 because they don't gel in with the rest of the data. Okay, so this is how we compute all the statistics with the help of Excel functions. Now what we are going to do is we are going to see how we can generate nearly all the things with the help of data analysis toolpack. So what we can do now is we can simply go to, if we want to do it with the help of data analysis toolpack, we will go back to this sheet where we have the data, the same data which has been arranged. What we can do now is we'll go to this data in the ribbon, we'll select this data, and in this data you need to have the data analysis toolpack or the tools enabled, which we had demonstrated. We had seen how to do it in the class. If somebody does not know how to do it, can always communicate to me and I'll explain this step. So in this data analysis, what we'll go to descriptive statistics. As soon as we click this data analysis, we get a lot of options. We'll go to descriptive statistics and we'll hit the button OK. Now in this descriptive statistics, what is the first thing that it asks for? It asks for the input range, that is the range of the data. So in this case, we have only one variable, which is this. Variables, as you already you know, they're always in columns. So this is variable 1. We could have had another variable 3, 4, and n number of variables. So what we'll do in this case, we'll just go here and we'll select the entire data and we'll hit the button and we'll come back, and our data is grouped in columns. So it is in columns. In Excel, the advantage is that if it is even in rows, we could have that data. Then it asks whether there is a checkbox, and it asks whether there is a label in the first row. But in this case, there is no label in the first row. So we just ignore this box. Now the next thing, it asks for the outputs. What are the places where we want the outputs to be, or what are the options? So if you look at it, it says you want the option, you want the option of, or you want to exercise the option of having the output on this sheet. So sometimes you want it on this sheet. So if you want it on this sheet, what you can do is you can simply bring your cursor here, and anywhere that you want the data to be displayed, output to be displayed. So I want it to be displayed here. I select this cell and the cell reference comes here. If I wanted it on a new worksheet, sheet 3, like for example, I already have two sheets, sheet 1 and sheet 3. So if I wanted it on another sheet, I could have selected this second option. If I wanted the output to be an altogether new workbook, I could have done that. Like for example, let's say I was preparing an exam paper. So I would have generated the output in an altogether new workbook. Now, what do I want? I want the summary statistics. This confidence level for mean, I'm not interested because I'm not calculating the confidence intervals here. Kth largest and kth smallest. So I am interested in finding out the minimum and the maximum. And I hit the button OK. So as soon as I hit the button OK, the entire output is generated for me. I have the mean, I have the standard deviation, I have the median, I have the mode, I have the standard deviation, the sample variance, the kurtosis, the skewness, the range, the minimum, the maximum, the sum, the count, the largest and the smallest. Okay, so you can see for yourself. If I were to compare this, it is basically the same data that I have generated. So mean is this, median is this, mode is this, and rest of the data has already been generated. But it does not. One of the disadvantages of using the Excel, data analysis tool pack is that it does not give you the quartiles. So you have to compute the quartiles yourself. Now the point is that the Excel function, you have to use the Excel function to compute the quartile and the interquartile range. So you have to do those things manually. But again, it is a far improvement on using Excel functions. It took me 2 minutes to do the entire thing, whereas it took me 18 minutes to do all those generate the summary statistics manually. Now I can do the same thing if I use the Excel template. So in this case, what will I do? I'll go and locate my uh, Excel template. So I'll go back and I'll go to the templates folder and I'll go to this basic statistics template, and I'll open up this template, and this template opens up and it's a very interesting template. Now what I need to do is on this green that you can see which says data, some data is already entered. This is from a previous calculation that we might have done. So what I have to do is I have to delete this data first, and then I have to go back and I have to select my data. So this is my data. I'll copy this data, Control C, and I just bring this data and paste the data here. And as soon as I paste this data here, voila, you can see I get everything. Okay, so I get the mean, which is you can see here, I get the median, I get the mode, and look at this. This is an interesting thing. I don't have to do all those manual calculations. Okay, so it tells me if the data was from a sample, that this is from a bigger population, what would be the variance, what would be the standard deviation, and if this data was from a population, what is the standard deviation and what is the variance. It gives me both the things. It gives me the range. It also gives me the interquartile range. So I don't have to compute these things manually, which I did even with the data analysis. So I got this range and the interquartile range. These have already been calculated for me. If I scroll down, I get the skewness and kurtosis. And again, the same logic applies here. If the data is from a sample, what is the skewness and relative kurtosis? And if the data is from a population, what is the skewness and the kurtosis? Then I get the percentile and percentile rank calculations. So if I want the 50th percentile, it is here. All these things are here for me. Okay, at this point of time, I'm not interested in these values. I'm more interested in the quartiles. So they are given 32, 51, 62, and the interquartile range is already given as 30, which was given earlier also. And I have other statistics as well. The sum is given, the size is given, that is the count, the maximum, the minimum, all the data is given. So I would always want to use the uh, Excel template for basic statistics from if it is from the raw data. So this is the raw data, and if I have only one variable, I can generate the data very simply like this, and I can report the data. The advantage is that with one click you get everything here, and everything, when I mean everything, because it also tells me if the data is from population. If it is from population, what should be the variance and what should be the standard deviation. It also tells me that it also assumes if this data is, if it is a data from a sample which is coming out from a bigger population, what would be the variance and what would be the standard deviation. So my life becomes very easy with this, and I can use this particular tool to you know generate summary statistics. Thank you.